Alright, so this is Physics Lab 5, the last lab. So here's our table of contents. We're going to go over the introduction of the lab, the video used, values, formulas, the code, the results, and some graphs, and then the conclusion. So the introduction. For this final lab, we have the option to make a lab of our own or choose from some options that were given to us. I chose to do the rope swing lab. The purpose of this lab, we wanted to investigate the energy principle and conservation of energy, along with oscillation and pendulum motion. And in the end, we discovered that energy is conserved throughout a pendulum motion by modeling a rope the same as a spring. So here's the video that I used to make these decisions on what I was doing. That was to us. So the values used. The mass was 70 kilograms, which was the average mass of a person. The length of the rope was 45.72 meters. The initial position was negative 45.72 in the x direction. And then the initial velocity was 0, and the spring constant was 11,000. So these are the formulas that were used. Energy conservation, the energy principle, delta K, delta U spring, velocity update, and position update. So this is the code. We created the object from the video analysis, and then we entered the spring constant, the length of the spring, the vectors, the system energies. We also did initial energies, gravitational force, spring force on the mass, net force, all the good stuff. And then we calculated energy changes. We also updated the spring, and then we plotted it. So this is what we got from the code on the left. And then on the right, I graphed with time on the x-axis and change in energy on the y-axis to find the change in energy versus time of delta K, delta U spring, and delta E. So in conclusion, energy is conserved throughout the experiment, and we can also see pendulum motion remained consistent, and the rope is accurately modeled by a spring in glow script. So these are some graphs showing the x position and the y position. And yeah, thank you.